Hi everyone, this is Jude, and in this video, I'm going to show you a counter I designed using D flip-flops with mode control. The idea is that it cycles through the binary representations of the decimal number 0, 1, 3, but the direction of the count depends on the mode switch. When is 0, the sequence is 0, 3, 1, but when the mode is 1, the sequence is 0, 1, 3, 0, 1, 3. And when we have an asynchronous clear switch, that we're gonna uh, force the state to 0. First, I created the state diagram. As you can see right here, there are three states: A, B, and C. A is 0, 0, B is 1, and C is 3. Where the whenever the mode is set to 1, it's gonna go from 0 to 1, and then 1 to 3, and then 3 to 0. And then whenever the mode is set to 0, it's going to do the opposite. So 0 is going to go to 3, 3 is going to go to 1, 1 is going to go to 0. So basically it's rotating between those three numbers, just in different order depending on the mode input. Next, I made the state table. This shows all the possible current states with the mode input and what the next state should be. From here, I filled the Q1 and the Q0 values, then figure out what D1 and D0 needs to be in order to get the next state. This is what helps me find the K-maps and the logic for the circuit. So in order to get the D1 results, I use the Q1 value right here and this Q1 value. And then for the D0, I use the Q0 and the Q0 value over here. As you can see, whenever we have 0, 0 and the mode is set to 0, we're going to go from A to C, just like we saw right here. When it's 0, 0 and the mode is 0, it goes to C. And then the same goes on for the rest. So 0, 0, 1. So 0, 0, whenever it's 0, 0 and the mode is set to 1, it goes to state B. So just like there, that's the second line. For step 3, I use K-maps to simplify the logic equations. The K-maps right on the left is the D1, and the one on the right is for the D0 flip-flop. From those, I got the two equations right here, and I'll be using these equations to do the circuit. Yeah. So I got the values for these K-maps from right here. For D1, we had 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0. Here's the final circuit in Logisim. I used two D flip-flops to hold the state and implemented the two logic equations using AND, OR, and NOT gates. That one is for D1, and this one is for D0. You can also see that I have the mode switch here, where when I toggle it, it switches the modes from 0 to 1. So like we said earlier, if we're in mode 0, the sequence goes 0, 3, 1. So let's simulate this circuit. We're going to enable the auto ticker, and we're going to set the mode to 0. As you can see right here, the circuit is going from 0, 0, 3, 1, 0, 3, 1. Then whenever I flip the mode to 1, it's going to go 3, 0, 1, 3, 0, 1. And right here is my clear switch. So whenever I hit this, it's going to force it to 0 no matter what. No matter how many clock cycles it goes through, it's going to go to 0. So now when I turn it off, it's going to go back to 3, 0, 1, 3, 0, 1. And these are the equations that we did earlier right here. So for D1, we had M prime Q prime 0 plus M Q1 prime Q0, M prime Q0 prime, M Q1 prime Q0. And as you can see right here, it's actually working and it's doing what we wanted it to do. And that's it for this project. This was a really good example of using state machines and D flip-flops to create custom counters. And thanks for watching.